Hi guys, welcome to Learning Guide. So in this video we will be looking into a library called as a Deep Image Search. So Deep Image Search is a library that helps us to build our AI based image search engine. So what is this image search engine? So image search engine, like I think you guys have used a Google image like search by image option where you give an input as an image and it will show you the all the relevant information, relevant similar type of an images as an outcome, right? Similarly, you have a Mintra or a Meesho e-shopping sites where you provide a dress pics and it will recommend you almost a similar type of a dress, right? So this type of search engine like were already present in a market, but what if you need to make your own search engine? So for that purpose, we have this library called as a deep image search. So this image actually, like, the contributor name is Nilesh. So he has worked around this deep image search library. It's almost for a 1 year he has been maintaining this repository. So for installing purpose, like you can follow along with me. So like you can install deep image search. Okay. Um, Search. So one thing you need to note down, guys. Um, so this library, like actually I've already installed in my device. But if you are a Linux user, I think there will be no problem if you install a dlib library. I think you will be good to install this specific library. Whereas if you are a Windows user, make sure you have installed VS Studio. VS Studio, like C++ build tools will be available in an Windows, VS Studios extension package. Like you can install those libraries. That basically helps us to like install the CMake. CMake is nothing but it is a it is an something that supports the cross platforms where Python can bind with the C++ because when something related to image processing or an image analysis has been done, you may require this specific tool. So please make sure you install the VS Code C++ build tools having a version more than 14 so that you will be having in all the available libraries for your any type of an image processing related task. Okay, once this image processing has been in like this deep image search has been installed, um, what we can do is let's try to import that libraries. Okay, from deep image search, like we have a set of modules such as load data set load data, sorry, um, and index, and another thing is search image. So these are the three modules like that are present in a deep image. Okay, I think okay, this is load data. Yeah. So these are the modules that are present in this specific package. So what is the use of it? So before that, let me show you what how my data set looks. So like let me import globe and my path is so this is my path of my data set. So let me give you the overlook of this data set, how the data set looks. Okay. So like let's define a function called as a plot image where it takes an x as an input and it basically what it does is it reads the plot. It actually reads the file and we will try to plot it. Means try to display it and let's it will just show the image. Okay. So okay, I think there is a problem. Yes. So now all I think all looks good. Now we have defined a path of our dataset and we have defined our customized uh, image showing utility. Now let's try to iterate over our dataset. Let's see how it looks. So let me show you what all the things are present in that data set. Um, so the data set is bit small, like it's as only 15 images. Um, so in the 15 images, so these are the 15 images. Let's try to see what all the things that are present in that specific data path. So let me show you plot image that takes a file name and it reads it and it will display it. So that is a simple purpose that we are doing. So you can see that we have a bird, a fruit, a tree, and car. So this is a simple dataset. We have only 15 images in that specific dataset folder. Now what we try to do is, now let's try to load it. How we can load it? As I said, from an deep image search itself, like we have an utility called as a module called as an load data, right? So what the load data basically do is, like let's give load data, and inside that, like we have an option called from folder. So from folder, if we provide an dataset folder there, okay. So yeah, why this error is, we need to give it in a form of a list. Okay, sorry, we need to give it in a form of a list. So if I give the list of this specific path, so how it basically looks is, the path is equal to path. So we need to have that thing in a form of an list. So we need to provide this list. Let's see how it what this load data helps us to do. So if we load that, means you can see all the files that are present in the specific directory will be loaded in a form of a list. So now we will be having this image file name list. Okay. So now as we have this image file name list, now what we can do is, uh, we have the concept called as an index. Okay. So in index, we need to basically provide the image list. So we have this image files name list, right? Let's pass that over there, and we have an function, or a we have the method called as a start. Okay, let's start that module. Okay, so what this start module basically do? So one thing, guys, this deep image search is entirely works on an uh, VGG16 transform learning. Okay, so this VGG16, what it does is, like we have given in 15 images, right? We have given in 15 images. So for the 15 images, um, we will try to extract the features by using this transform learning, and we will store it in a specific place. And along with that, even we will try to store all these file names in a specific file again, dot in a form of an uh, uh, like in a form of an text format. We will keep it, we will store the features as well, we will store the names of the files as well. So once this features has been like extracted and saved, right? If we give a new input image, for the new input image also, it extract the features by using this VGG16 uh, transfer learning technique. We will extract the features, and for that feature we will compare all the feature, we will use a Euclidean distance for all the features that we have already extracted from our data set. So what it does is, you can see, it try to extract the features. Once the features have been extracted, we will store that in a folder name called as a metadata file. Inside that we have an image data features. So image data features is nothing but the features that we extracted from our transfer learning, and that has been stored in a form of an Excel file, and save the index file. Index file is nothing but we have a file, right? For each file we will be we will be storing it in a form of a list, and it will be having an each file will have an index. So that what happens is, if we give some new image, we will extract the features and compare the features with respect to this image data features, and it thinks the fifth image feature is very close for the new incoming sample feature. Then we will pick up the fifth index file from this image features vector, and that will be having a file path, and that will be showcase for the end user. So based on this comparison, we will retrieve the outcome which is almost similar to the input image. So that is the purpose of this specific index.start. So this one is actually, like, it is not required to run every time. If you have set up, if you have a data set in a specific folder, but initial stage you need to use this technique for extracting the features and storing it in an metadata files. If you are already have all these metadata files, means there is no need to again do this index.start, because you already have all the features of the images that is present in your dataset. Now let's see whether we have that metadata folder or not. So let me do that. So if you see here, we have this metadata files that has been created recently. So like inside that metadata folder, like we will be having this image data features, this image data features, as well as their file names with their index will be present. So now what we can do is, we have anyway we have this image list, right? Image file name list. So let's pick up one image. So this will be our test image file. Okay. So let's see how this test image file basically look. So let's plot this as an image, and let's see how it looks. So we have a bird. So let's test it whether we will be able to retrieve the similar kind of an outcome or not by having this whatever the feature metrics we have, right? So based on that, let's see how much accurate the model is, because we have not trained on a news data set, right? So for testing purpose, what we have is, we have this search image, right? Inside this search image, you can there is a utility called as a get similar images. Okay, get similar images basically will take an image path and the number of images you need to retrieve. So let's give the image path is equal to text, sorry, it must be test, right? Yeah, test image file. um, so it will be a test image file, and number of outcomes must be 2. Why 2 is, like, let's see why it is 2, because it is actually something looks really good. Why? Because the first uh, closest point will be the same image itself, right? Like, if there is an already image that is present in a same image that is present in your data set, means, like, that will be your first outcome, and the second outcome will be the second most similar image, that is second most similar image for the input image. So that's why, like, I have given it as a 2. Let me show you what things we will be retrieving from this result parameter. So in result, you can see it is a dictionary with an index vector as well as its corresponding file name. So now let's try to plot this. So how we can do this? For I in result dot values, let's try to plot it. Let's try to plot each image. That has been showcased here. Like, we got only 2, right? So for that, to buy, because they have given the number of images is equal to 2. Let's try to see what is an how the images look. Okay, sorry. Yes. So here you can see the first image is almost same as an almost not almost, it is the same as an input image, because that same feature is present in our data set as well. So that's why, like, it's almost the same image has been retrieved. In a second position, you got another bird, which is almost similar in form of an like see, like it has been standing in an wood, and it has a beak. Uh, so like the beak is bit sharp. So that's why like almost the same similar type of an image has been uh, extracted with our minimal data set. That is really good actually, because we have given just a 15 images, right? So yeah, so this is how we can do. Let's try with some another image as well. Let's go with some random number. So okay, no, let's give it something else, not the bird. Yeah, now we have given. Now we have a car. Let's try to do how it looks when we try to find a similar image. Okay, so okay, it has been exported. Means the result has been arrived. Now you can see the first image is almost all is same as an input, and second image is also a car, which is standing in an road, and background is having an green shade. So yeah, so similar image has been obtained as an output. So now we have this utility. Now we have this library, right? Let's try to make an minimal web app. Okay, by using Gradio, like we can make an minimal web app. Let's try to see like how we can make the minimal web app by using this. Let's import Gradio. Let's import Gradio as gr. If you don't have Gradio, I request you to run this command like pip install gradio. So this will help you to install the gradio in your environment, as gradio is already installed in my device. So like again we cannot install it, right? So yes, so and apart, let's try so let's see like how we can make the basic outcome of this. So with gr dot blocks, so let's create a block first. Let's name it as app. Okay, inside this app, let's make a column with geo dot rows. Let's have a rows first, and later we can go for a column. um, Inside this rows, uh, let's give an input string, where input string, we can say it as a file name. So basically what we need to do is we need to give a file name, and we need to see what is an outcome of that file name, just like this. But we need to have it in a form of an web app, right? So let's give it as a file name, and it is a type of an text. We can label it as an image file path. Okay, and with column, not column. Yeah, like what we can do is instead of column, with row only. Uh, Outside the row, let's have an output is equal to gre dot text, um, label is equal to suggested image file. Okay, this will be our output. Now let's have a button. So if we click on that button, it will take this file name. Okay, before that, let's try to run how the app looks. So now we have this variable, right? We can just use app dot launch. So it will launch our gradio app. Okay, I see there is some error. Okay, this is yeah. Okay, again an error. Gradio has no attribute called as an row. Sorry, it's row. Actually, it's not a rows. It's row. Okay. Um, as demo. Okay, I think it's app dot launch is not working. Let's see why it is not working. I think it must work, but I'm not sure why it is not working. Okay, it's not lunch, it's launch. Yeah, now we have the simple uh, G radio app that is running in our Jupyter notebook itself. but what is like we have not defined the utilities of this specific placeholder. So what we can do is now let's create a button. Okay. Now let's create a button with like there is a geo dot button. Let's label it as submit. Let's label it as run. Um, okay. Now on like as the name is suggested. Now we can what we can do is let's try to see again. Yeah, now we have this. But on clicking it, we must take the input from this file and we need to show the suggestion input file as an output. Here we need to give an output in a suggestion image and file. Here we need to give the input. So for that purpose, let's make a function like define updater. So updater will take an file name. Okay, and once the file name has been done, we need to use this search image concept, and let's get a similar images for an image path as a file name. Okay, why? Because we need to provide a file name there. So it takes a file name, and number of images we need to retrieve is 2. Okay. Now like we need to give the result file path, right, as an output. So what we can do is we have this result as a dictionary format, right? We can use the values, and one thing is we cannot do the indexing here. Like as per as we saw, like the first image whatever we are seeing is almost same as the input we are giving, right? So we don't need that thing to happen in this case. Like whereas if it is an uh, having a used data set means you can directly pick up the index 0, but in our case as the data set is so minimal, let's pick up the index 1. So but we cannot do the indexing in this dictionary dot values because it will raise an attribute error. So for that, what we need to do is we need to typecast this dictionary values into a form of a list, and later we need to use the indexing. What I'm doing in an indexing, I am selecting the last one because there will be two elements. I will be selecting the last one, not the first one. Now I need to return it. Return the result file path. Alright. Now let's try to run. But even though like we have wrote this function, we have not linked it anywhere. So what we need to do is now we have this button, right? For this button, let's on button we have a function called as a click, right? Inside this click, you can see there is an fn that takes the callable function, input that takes the input, and output which takes the which returns on the output parameter, means on the output component. So what we can do is like let's link our function updater for the button dot click, and inputs will be, let's give it in a list. Okay. As I said, this will be our input, right? So the input placeholder will be file name, and outputs will be again a list, and whatever the output we will be getting from this function need to be displayed in this specific placeholder called as an output. So now we have these things ready. Now let's try to run the app. Okay. Now as it is running, let's try to see, like we are getting an error. Why? Because we are not given anything to read, here. So let's give a file name here. So let's give the text image itself, text image file. Let's copy this and let's paste here, and let's try to run. So you can see it is getting processed. It is getting processed, and yeah, now we got this as an output. But yeah, like we are not showing the images, right? Um, Now we are getting this as an output. So let's see like how it actually looks. If I use plot image and let's try to see how it looks. So yeah, I'm getting this car. um, for this for this input, yeah, this is an output. Yeah, we are able to get that, but we are not displaying it, right? So what we can do is, um, let's have two placeholders. One is input image, okay, which is gr dot image, like image thing, and another is, instead of this, let's instead of text, let's convert it into a form of an image. Okay, now what we can do is, um, like we cannot give an input image directly, right? Because our model will take the path, not an image. So for that purpose, um, like here we have this file name, right? Let's create input image object, and let's try to read this image file. How we can read is, like we can import pillow. We have a pillow library, right? Inside that pillow we have a image module, so we can use this. So what that helps is, like we can call the image dot open, and if we give the file path, it will load up the pillow image just like this. So let's see like how it actually looks like. Image from pillow dot image dot open. If I give the file name, it opens up the image, right? So here also we are creating we are opening the file and reading the image and storing it in this object. Same way let's do for this result file path as well. So for result file path, let's have a result image is equal to image dot open. Let's open result dot file path. Okay, and now let's return the result image. Okay, now let's try to run it. So here you can see we have a suggestion image file, and we have an image file path, and this is an just a placeholder. Now let's try to uh, what copy provide the file path, provide the test file path. So this is our test file path. Let's paste it here, and let's try to run. Okay, after running, it's just showing it's running, right? um, okay, you can see we got an output here, but we have not got an input here, right? So for that purpose, what we can do is, instead of giving a multiple instead of giving a single output, we can actually convert it into an tuple. Okay, the first in a tuple, the first image will be an input image object, and then second image will be an result image object. Result image object. Okay, so here we are giving a single as an output, right? So now what the thing is, um, like even let's give the input image also. So as the target function is returning a two objects. So the first object will be fed for an input image, and the second object will be fed for the output image. The second object is an output image object. The first image is an input image object. So we have both things defined in a form of a list for the outputs. So now let's try to run. On running, if I provide a file path, let me give it this file path, and let's try to run. You can see this is an input block, this is an output block. Once I provide an input, you can see the input image here, and the output suggestion image file here. Why it is happening, how it is working is, like the first argument is an input image object, is mapping for the input image placeholder, and that is present here. Whereas the second object the second object from the updater is mapping for an output placeholder which has been mentioned here. Like this, we can have our own customized uh, AI-based image search engine. So I think you guys liked it. If you liked it, please like, share, and comment it out how was the video and where I need to improve. Thank you guys. Happy learning.